Welcome to Study Time, a televised home learning program produced by Rwanda Education Board.
Hello students, welcome again to the TV learning program. This is Teacher Pasco, and today I will be with Senior 1 students. Going ahead with unit number 5, definition of atoms. We explained what elements are, and we also discussed the different compositions, particles which compose the atom. We know some of the properties of those subatomic particles. And today we will go on to go deep and find the location of those particles, how some of those particles, the subatomic particles you have seen, are distributed in the atom. But before we start our today's lesson, let us have a look at the objectives of today's lesson. What you have to know at the end of this lesson. At the end of this lesson, you should be able to write the electronic configuration of elements. At least you should be able to write the electronic configuration of the first 20 elements. And when we say the electronic configuration, we mean the distribution of electrons in elements. And number 2, you should be able to draw diagrams to represent the distribution of those electrons in the atoms. So we can represent the distribution of electrons by using diagrams, or we just use numbers. So you should be able to do it in those two different ways. And before we go deeper in our today's lesson, let us have a revision exercise. Here we have an element which is represented like how we did it. Remember, this is the chemical symbol for the element, and Ca represents calcium. You remember calcium. What we have here is the atomic mass, or the mass number, and here it is the atomic number. This is the chemical symbol of element number 2, and you will complete this table. You will identify the atomic number of this element, the mass number of that element, number of neutrons, protons, and electrons. And for element number 2, you will also identify the atomic number, mass number, and the proton number. Here we have been given the neutrons and the electrons. And for the last, you will also have to identify the element. So you will use your periodic tables. You look at the periodic table and you identify the element which has atomic number 11. It also has the mass number 23. So with the atomic number and the mass number, you will represent it like this. Just like how you will do the same for X. And then you complete the neutron number, protons, and electrons. You have 2 minutes to try the exercise. Good. So to answer those questions, here there is what we have to use. There is a formula. Remember, we said that the number of protons is also called the atomic number. And its symbol is Z. That is the atomic number. And the number of neutrons, which is represented by N, it gives the number of neutrons, the other nucleons, or the particles which are found in the nucleus. And when we add the number of protons to the number of neutrons, we get the mass number, which is represented by letter A. And if you want to represent an element, you use X, which stands for the chemical symbol of a given element. And here we have the mass number, while on this side down we have the atomic number. So this is the general representation of a given element whose mass and atomic numbers are known. So if we go to this question, we have calcium with 40 and 20. 40 is in the place of the mass number. So for this mass number here, we have 40. So for calcium, the mass number is 40. And for the same element, the atomic number, which is always down here, so it is equal to 20. So we have 20 here, the atomic number. And next, so we have the answers for atomic number and mass number. Now we have to calculate the number of neutrons. From this formula, it can be seen that the number of neutrons is equal to mass number minus the number of protons. So it is A minus Z. And considering the example we have here, it will be 40, the value of A, minus 20, the value of Z, and we get 20. So the value of neutrons is also 20. Remember, we said that the atomic number, by definition, it is this one represented by Z. It is equal to the number of protons. Good. So being equal to the number of protons, and we have its value, which is 20, then we also have the number of protons. The number of protons is then 20. What is the number of electrons? In the same particle, let us consider the statement we have here. In a neutral atom, the number of protons is always equal to the number of electrons. So being equal, and we already know the number of protons, we can determine the number of electrons. So the answer for this space here is also 20. So the atomic number is 20, mass number is 40, neutrons, it's 20, 20, and 24 electrons. Number 2, we have X. It is an element which is unknown, and here we have the number of electrons. What can we deduce from this number of electrons? It is said that in a neutral atom, the number of protons is equal to the number of electrons. So if we have the number of electrons, we can deduce the number of protons in a neutral atom. And because of that, then here we have the number of protons, which is also 17. So for this X, the element X, the proton number is equal to the number of electrons, and it is 17. And the value of A and that of Z can also be calculated. How can we get the number of protons? The number of protons is equal to 17, so the atomic number is 17. Atomic number is the total number of protons. And A, which is the mass number, it is equal to the protons plus neutrons. How many neutrons do we have? We have 20. So 20 plus 17, we get the number of all particles in the nucleus, and we have 37. So the mass number for that X is 37. And how do we represent it? It will be X with 37, the mass number, and 17, the atomic number. We go to the next and the last. We have mass number, which is 23, and atomic number, which is 11. If you check well on your periodic table, you will find that the element which has atomic number 11 is sodium. So we have sodium, which has atomic number 11 and mass number 23. From these two values, we can determine the number of neutrons, which is A minus Z, and that is 23 minus 11, and we get 12. So, with the number of neutrons and the atomic number, we have the proton number. Proton number, which is the same as electron number, will be 11 and 11. And we represent this sodium like this, 23 and 11. And we are done with the exercise. Now, we have been saying that protons and neutrons are located in the nucleus, and electrons are located around the nucleus. Imagine how we know the solar system. With the solar system, we know that we have the sun in the center of the system and the planets which are always revolving around the sun, moving around the sun. That is what happens inside the atom. We have the nucleus, which is in the center, and the electrons which are moving around the nucleus. But do you think that all those electrons are located at the same distance from the nucleus? No, it's not like that. But different electrons are located at different distances from the nucleus, and those distances are the ones we call electronic shells. So electrons in an atom are located at well-defined distances. The well-defined distances around the nucleus, we call them electronic shells. You know how, if we have the nucleus here, for example, consider this to be the nucleus, then around the nucleus there will be some electrons. And at another given distance, there will be other electrons. So we have electrons which are moving around the nucleus, but at different distances from the nucleus. And we call those distances electronic shells or energy levels. Why are they called energy levels? You will get a deep understanding of why they are so called when you will be in Senior 4. But they are, in simple ways, we can say that they are called energy levels because the electrons which are in a given shell, they contain a given amount of energy, specific for that shell. Very specific for a given shell. And we know that we have a maximum of 7 energy levels in the atom. These shells can have values from 1 up to 7. and they can be named K, L, M, N, O, P, and Q, like this. We have energy level number 1. This is the nucleus. This is energy level number 1, which can also be called K. This is energy level number 2, which can also be called L. We have energy level number 3, which is called M, and so on. And the highest value, the highest number of the energy level is 7. And those are the respective names. And another question is this: do you think all energy levels can contain the same number of electrons? Do you think all energy levels, from the first energy level up to the 7th energy level, they can all contain the same number of electrons? They can't. So they contain different numbers of electrons. Why is it like that? It is because as you go further from the nucleus, as you move further from the nucleus, you can see the distance is increasing. The size of our energy level is increasing. So as it increases, the energy level or the electronic shell gets the capacity of accommodating more and more electrons. And how do we know the maximum number of electrons that can be in a given energy level? We use this formula. The maximum number of electrons that can be accommodated by a given energy level is given by this formula, 2n squared. And that n represents the number of shell energy level. For example, for shell number 1, the maximum of electrons that can be there is 2. Very simple. We have the formula. It is 2n squared. So for the first energy level, n will be 1. And 2 times 1 squared, we get 2. For energy level number 2, we have 2 times 2 squared, and then we get a maximum of 8. For energy level number 3, we have 2 times 3 squared, and we get 18, and so on. For the fourth, it is here in the table. We have 2 times 4 squared, and that will be 32. I think everything is clear, understandable, right? Yes. And how do we represent the distribution of electrons in those different energy levels, those different shells? We have started here, but now we are going to use the numbers. We have an element, let us say we have an element which has 11 electrons. That is sodium. Sodium has 11 electrons. For these 11 electrons, we know that the first shell, that is K, it can contain a maximum of 2. The second L, 8. And M, 18. N, 32. Now, for the first energy level of sodium, we have a maximum of 2 electrons. How do we do this? We have 11 minus 2 to fill this first energy level. We remain with 9. And then, because we have already filled the first shell, we go to the next. The next can contain a maximum of 8. And if we remove the 8 we have used, 1 remains. And then we go to the last, which will not have the maximum because we don't have those electrons. Here I'm saying that the maximum that can be there is 18. But it is not necessary that you will always have 18. You will have what is present. And if it reaches 18, then the third shell will also be full. But if it is not full, there is no problem. You just put there what is available. If we go to the other example, we have so many examples here. We have sodium, the one we have used. The atomic number is 11, and that is the number of electrons. So we have 2 electrons in the first shell, 8 electrons in the second, and 1 electron in the third shell. Here we have the distribution on a diagram. You can see that on the diagram, we have the first shell, which contains 2 electrons, and the second shell, which contains 8 electrons, the 8 electrons, and the third, which has only 1. If we go to boron with 5 electrons, the configuration is 2 and 3. 2 in the first shell and 3 in the second shell. On the diagram, we have 2 electrons in the first shell and 3 electrons on the outer shell. You can see that the nucleus is also represented by a circle. And we have more examples. Now, from the examples we have here, I want you to try this. Write and draw the electronic configuration of each of the following elements. Calcium, which has Z20, and sulfur, which has the atomic number 16. Just 2 minutes. For calcium and sulfur, the atomic number of calcium is 20, and that of sulfur is 16. Try. You can make it. You start with the first shell, fill it. If some of the electrons are remaining, you go to the second shell, you fill it. If some of the electrons are remaining, you go to the third shell, and so on. Very simple. Good. Now let us try and see what happens with calcium. Calcium has 20, the atomic number. So the number of electrons is 20. So we have 2 in the first energy level, K. L contains 8. M contains 8. And for N, we have 2. And here there is something which is very important. There is an exception. Why do we have 8 electrons and we go to the 4th energy level before we get 18? Remember, we said that the 3rd energy level can accommodate 18 electrons. But here we have not filled the 3rd energy level, and we have gone into the 4th energy level. This is the exception. And the exception we have here is done for group 2, for, let us say, for potassium and calcium. Detailed explanations will be given to you when you will be in senior 4. You will find detailed explanations explaining why we have it like that. And if we go to sulfur, what do we get? For sulfur, we have 16 electrons. And the first one, K, contains 2. After removing 2, 14 will be remaining. And when we go to the second, and we take 8, now we have used 10. and 6 are remaining, so we go to the third energy level. So this is the electronic configuration of sulfur. For this sulfur, you can also represent it by using a diagram. So we have sulfur here, and the 2 electrons in the first energy level, 8 electrons in the second energy level, and 6 electrons in the third energy level. 6 electrons in the third energy level. So it is something very simple. Just consider the electrons which are remaining and you go to the next energy level. If you don't have a number to complete that energy level, it's okay, there is no problem. You just put there what is available. Now let us have a look at the homework. You will try. Write and draw the electronic configuration of the following elements. Potassium, which has 19 electrons, oxygen, which has 8 electrons, argon with 18 electrons, aluminium with 13 electrons, and fluorine with 9 electrons. Remember, one of the objectives we had is that you should be able to write the electronic configuration of at least all the first 20 elements. So these are the elements you will try. Remember, don't forget to write the numbers, and you also draw. Those are the 2 ways of representing the distribution of electrons in the atom. And when you will be done, do not hesitate to try all the other elements to complete the 20 elements in the periodic table. First 20 elements. You will make it. So, I think we are close to the end of this lesson, and I hope you have understood everything. We will see each other next time with a new lesson. And I'm inviting you to revise, always revise. For further reading, you can visit the e-learning portal of Rwanda Education Board. Thank you very much for your attention. See you next time.